How's it going, y'all? Today, 1.4, writing linear equations. So looking at your objectives here, we're going to be able to write an equation of a line given a slope and point on the line and write an equation of a line parallel or perpendicular to a given line. We're looking at standard FLQE2, which is creating symbolic representations of linear and exponential functions, including arithmetic and geometric sequences, giving graphs, verbal descriptions, and tables. So again, not focusing on exponentials today, not looking at sequences today, but we're just looking at the linears, again, setting the foundation for everything we're going to do the rest of the semester. Most of what we're doing today is from Algebra 1, a little bit from geometry when we talk perpendicular and parallel lines. So let's jump right in. Remember that the slope-intercept form of an equation is y equals mx plus b. Y equals mx plus b. This one should be ingrained in your head somehow. And so when we look at a line on the graph, remember that the y-intercept is the b, and that order pair would be 0, comma b. And then the slope, if we take a second point, we could find the slope of that line. And so looking at this graph here in example 1, write an equation in slope-intercept form for the line. So y equals mx plus b. And you'll see the steps I've listed below. Find the slope, use the slope to find slope and a point to find the y-intercept, and substitute the y values in. We're going to talk about point-slope form in a second, and I would recommend using that if we don't have a nice, easy y-intercept. But we are going to go through these steps here. So step 1, find the slope. And so as we look at these 2 points, here and here are 2 good points that we have. This one's at -4, 4. This one's at 2, 2. So m is equal to 2 minus 4 over 2 minus -4. So that gives me -2 over 6, which is -1/3. Use the slope and a point to find the y-intercept. So what this step is we're plugging into y equals mx plus b. And so it says use the slope and a point to find the y-intercept. Well, the slope is -1/3. Well, what does it mean use a point? So we have this x and y sitting here. X, y. And so what it says is take one of these order pairs. I'm going to take 2, 2, for example, because that's really easy to use because you can't confuse the x's and y's because they're the same. And you plug it in for the x and the y. So 2 was y, 2 was x, plug in for b. We're going to end up with a fraction here when we multiply this out and solve for the b. So we're going to add the 2/3 across. And so we're going to get 2 plus 2/3. That becomes 6/3, which gives us 8/3 is equal to the b. And so what that means is that substituting the values in, we get y equals -1/3 x plus 8/3 is the slope-intercept form of this line. So again, as we look through this problem, our key steps, when we're doing it this direction, again, we'll use point slope in a minute, but if we're going to use slope-intercept form, find your slope first. That's what we did up here. Use an x and a y, one of the order pairs, to plug in. Find your b, substitute that back in. That's what we did this last step. Okay. Example b, we've got a similar line here. This one, we have a nice y-intercept. We can find a slope very quickly. We're going down 1. These boxes are in halves because we have 2 and then 4. And right 2. And so my slope, we went down 1, right 2. So my slope is -1/2. My y-intercept is 4, so y equals -1/2 x plus 4. Again, if you have a nice y-intercept, you have an easy slope to discern, it's very quick to get into slope-intercept form again, and I don't see issues here. Point-slope form, remember this one, again, we don't use it as often, but it is very useful. I actually use it more than you would think, because if the y-intercept is not nice, this will get you to a form of the equation. And so the point-slope form of the equation of the line is y minus y sub 1 equals m times x minus x sub 1, where x1 and y1 are the coordinates of a point on the line, and of course the m is the slope. And so what that means is given information, so we'll look at example A here, If we're given the point 5, -2 with a slope of -3/5, we're going to plug into our point slope form. This is my x1, this is my y1. So y minus -2 equals -3/5 x minus 5. If we want to keep this in point slope form, we're going to just fix these signs right here. So y plus 2 equals -3/5 x minus 5. This is point slope form, and if we're just looking for an equation of the line, it's perfectly acceptable. Just like using vertex form of a quadratic equation, we can use that to graph from as well. Now, if the directions were to give, like you'll see example B, to give it in slope-intercept form, we got a couple steps to go because we got to make it look like y equals mx plus b. Okay, so finishing off example A, if we want it in slope-intercept form, there are two steps are this. Multiply the -3/5 out. So y plus 2 equals -3/5 x. -3/5 times -5 is a +3. We will subtract the 2 across, so y is equal to -3/5 x plus 1. So this would be the slope-intercept form of the line. Okay? So again, it depends on how the question asks. In this question, it was just to give an equation. So we could have stopped at this line here at the point slope form, or we could continue to slope-intercept form. Again, if it's multiple choice, like on the ACT or SAT, understand that it could be given to you in any form and be able to manipulate between those forms. So try example B on your own here. What is an equation in slope-intercept form of the line, given that the slope is 2/3 and it passes through -3, 1? So pause the video here, try it yourself. Did you pause the video? I hope you did, because here we go. So we're going to start in point slope form because, again, that is the easier way to start when you're given a point in the slope. So y minus, so this is our x1, y1. So y minus -1 is equal to 2/3 x minus -3. And so y plus 1 is equal to 2/3 x plus 3. Make sure you get your signs right. And then we're going to multiply out because this one did ask for slope-intercept form, so we cannot stop. Y plus 1 is equal to 2/3 x plus 2. Subtract the 1 from both sides, and so y is equal to 2/3 x plus 1. This would be the slope-intercept form of that line. If you got that, great, good job. If you didn't, go back and look at your steps. See where you made a mistake. Did you plug in your x's and y's in the wrong spots? Did you put the -3 on the left side and the -1 on the right? Did you multiply that 2/3 out and get something kind of weird? That fraction is not always going to multiply out nicely. Like these first two examples, 2/3 times the 3, it cancels the fraction. And in the previous example, it was 3/5 and the 5. They canceled out the fractions. Not always going to cancel it out. You're going to have to work with fractions through these problems. Okay. We look at example 3. Write an equation given 2 points. Well, slope formula or slope-intercept formula and point slope formula both require to have what in them? The slope. So if I'm given 2 points, I've got to find what first? The slope. So m is equal to y2 minus y1 over x2 minus x1. I'm not going to use my change-of formula here because I want to be able to label out these points and plug them in correctly. And so I'm going to get 7 minus -3 over -3 minus 2. The double negative becomes plus, so that's 10. This is -5, so we get 10 divided by -5 is -2. Now, here comes the option. I can use either ordered pair for the next step to plug into point slope form. It depends on the numbers on what you want to use. Everything's an integer here, so there's nothing in terms of fractions that you don't want to deal with. So I would just go with smaller numbers. So I'm going to choose the 2 -3 to use. So y minus y sub 1 equals m times x minus x sub 1. That should not be a 1 there. X minus x sub 1. y minus negative 3 equals negative 2x minus 2. Again, make sure you got everything plugged in right. The 2 is the x sub 1. The negative 3 is the y sub 1. Y plus 3 is equal to negative 2x plus 4. Multiplying out here. And subtracting the 3 from both sides. Again, it didn't say it had to be in slope-intercept form. I know most of us are more comfortable in slope-intercept form for our final answer. So again, this would have been, well, kind of a hybrid between. We would have fixed the signs on this side, but not multiplied on the right side to be in point slope form. But this is the answer in slope-intercept. Okay. So I got a second example here. Again, I want you to try this one on your own. Look at the example here. It's what is the equation of the line that passes through 2, 5, and negative 1, 3. Look at the steps we just did. Try it out. Pause the video now. All right, here we go. So, did you get this slope right? So we have our x1, y1, our x2, y2. And my recommendation is to always write out your formulas first. That way you don't make a mistake in plugging something in the wrong spot. It's an error prevention process. And so we're going to get negative 2 over negative 3. Double negative becomes positive. I don't know why my pen just wrote a 4 for some reason, but that becomes 2/3. And so now we're going to take that slope and plug it in. Now, when we're thinking about where we want to plug in this fraction, remember our slope is the 2/3 here. Do either of my x's nicely get rid of this 3? If one of them does, great, use it. If it doesn't, you just got to go with what you've got. I'm going to choose this order here because they're both positives in this case. I could go with the negative 1 and 3 if I wanted to. Again, it's personal preference there. And if we're using point slope form as our final answer, it's not an issue. Whereas slope-intercept form, we will get, point slope form will, you'll see different numbers in there, but it will be the same line that comes out when we graph it. But in slope-intercept form, it will be the same equation in the end. 5 is y and the 2 is x. So when we distribute this 2/3, we're going to get negative 4/3. We're going to add the 5 to both sides, and 5 is equal to 15/3. And so negative 4 and positive 15 gives me 11/3. So again, I could have stopped at this line for point slope form, or I can go here for slope intercept. Okay. Questions there. Again, if you got questions anytime through this video, you know what you got to do. Stop, ask, get your questions answered. Don't wait till the end of the video to wait on that. Okay. Parallel perpendicular lines is the last thing we're looking at in this lesson today. Parallel lines, remember, our two non-vertical lines are parallel if and only if, I'm going to talk about that language there in a second, if and only if, put a pin in that. If and only if they have what type of slope? Well, look at our example below. Look at these two parallel lines. They're parallel, right? Because they look like what? Railroad tracks. Railroad tracks are parallel. Why are they parallel on the graph? Because the two lines have what type of slope? The same slope, right? And so we look at those two lines, and if we actually look at the equation of these lines, this one is y is equal to 3x plus 5, and the blue line is y is equal to 3x plus 1. The slopes are the same. The y-intercepts are different when we look at parallel lines. Okay. Perpendicular lines, the two non-vertical lines are perpendicular if and only if. Okay, still putting a pin in that language there for a second. The product of their slopes is -1. So think about for a second, what two numbers could you multiply together? So I need a number A and a number B that multiply together to give me -1. Well, I can manipulate this equation a little bit. I can divide both sides by the B, and I get that B is equal to -1 over B. Well, this starts to get us into thinking about how would I get this fraction? Well, let's try some numbers. If I've got the number 3 in for A, -1 divided by what gives you the B, right? So now I need to solve for B. So how do I get that? Well, we can multiply both sides by the B again, right? So I can multiply this back across, and I get that 3B is equal to -1. And if I divide both sides by the 3, I get that B is equal to -1/3. So I started on one side with 3, but I end the other side with -1/3. So what happened to our number? Well, there's two things that happened. Well, one, the sign went from positive to negative. And so the word we're going to use there is opposite. But then it went from a 3 to a 1/3, and so that flips that fraction. And remember, the wording for flipping a fraction is called the reciprocal. Reciprocal. And so that is your word of the day, opposite reciprocal. Make sure you send that to my email, opposite reciprocal. And so when we look at the two slopes of these lines, we look at this first line here, and it starts at 1, it goes up 3 and right 1, so it has a slope of y is equal to 3x plus 1. It's still that same line from the previous graph. But our new line here has y is equal to -1/3 x plus 5. So my y-intercepts don't matter in perpendicular lines. The key that matters, remember perpendicular means they meet at a right angle, right? If I can draw a nice square. But the key is that their slopes are opposite reciprocals. Okay, so two problems we're going to look at real quick. First problem, write an equation in slope-intercept form, key there, what form we're going to put it in, that passes through 3, -2, and it's perpendicular to the line whose equation is y is equal to -5x plus 1. And so we steal the slope. So if our first slope, the slope of the initial line, is -5, I'm looking for perpendicular here. Remember, perpendicular means opposite reciprocal. So what is the opposite reciprocal of -5? +1/5. So I'm going to take this slope and this point and plug them in. So y minus y sub 1 is equal to m times x minus x sub 1. So y minus -2, make sure you use parentheses, 1/5 x minus 3. It wanted slope-intercept form, so I've got to do the work through here. Multiplying out, that'll be 3/5 minus the 2. And remember that -2 would be -10/5. So y is equal to 1/5 x, -3 and -10 would give me a -13/5. So there's my answer to part A. So one last time, I'm going to ask you to do part B here. So look at the example. Write an equation for the line that passes through 3, 5, and it's perpendicular to the equation of the line, whose equation is y equals 3x minus 2. Pause the video now. All right, last example here. Let's go through it. So we start out with a slope of 3, which means my perpendicular slope should be -1/3. Going back to the example we looked at above, talking about opposite reciprocal. Don't forget your word of the day. And so we've got y minus y sub 1 is equal to m times x minus x sub 1. There's no problem if you want to use slope-intercept to plug in for this. Again, my general trend is if I have a point and a slope, I'm going to plug in the point slope. I don't want to have to go search for that b and then come back to plug it back in a second time. So y minus 5 is equal to -1/3 x minus 3. So y minus 5 is equal to -1/3 x plus 1 as we distribute the -1/3. We add the 5 to both sides since we don't have a fraction this time. Y is equal to -1/3 x plus 6. This one didn't ask for slope-intercept form, so I could have stopped here for point slope, or we work all the way down to slope-intercept form. Hope this has helped today. If you're done with this, make sure you get on your assignment. Otherwise, have a good day.